Hello everybody, in this video we will see how the current collector current of a BJT vary as a function of the voltage between collector and emitter. So we have a typical curve of the transistor, which is this one for two different values of the base current. So for this we build this circuit with a NPN BJT, 200 kilo ohm resistance on the base, polarization tension of the base of 6 volt, 1 kilo ohm here on the collector, and here in the collector between ground and collector we have this wave, 3.5 volt of offset and 7 volt, so that we have of amplitude. So we have an exclusion between 0 volt and 7 volt. So we set up the circuit. We have here the BJT, the 1 kilo ohm, let's say here 1 kilo ohm resistor on between the collector and the positive voltage of this source, and this on this side we have 200 kilo ohm on the base, and this is the battery polarizing the base, this 6 volt here. And on the collector side we have this red and black cable which came from this function generator, in which we have 3.5 offset, 7 volt peak to peak, and 1 kilohertz sine. So now we want to see these signals on the oscilloscope, so I connect the two channels, channel 1 of the oscilloscope, to see the voltage between emitter and collector, and the channel 2 between ground, so the common ground, this ground, and the output of my signal generator. So this is my wait a second, this is my input signal, this one between 0 and 7 volt here, and this one is my voltage over time here between collector and emitter. Now I change the display and I see one curve as a function of the other. I can change the division, volt division, so I have the typical curve that I expect of the collector current as a function of the voltage between collector and emitter. And if I change the voltage on the base, so if I change this value here, I change current on the base, and so I will change my curve like this. So let's try this, and I have here my 6 volt, and actually I'm changing my curve. I can move this with this command so I can see the full curve. I still change again the base current, and I have all the range of operating point of the transistor. Thank you for watching, hope this could help.